Hey guys, so we will be learning something today that will be quite beneficial for us in the long run, because it will teach us about some internal operating system concepts that I also don't know yet. Okay, so the topic that we'll be looking on today is thing called accessing a memory location from from a different process. For example, let's consider uh, this X process, which has some memory location A, and it passes this information downwards to another process Y, and or maybe Z. X passes this information to Z. Now, will Z be able to access the memory location A? So we have process X and process Z. So we have these two processes and we are trying to access the common memory location A, and the memory location A is part of process X. Okay, so let's see if this happens or doesn't happen. So I am also not aware whether it will happen or not happen. So let's try and open a file, and we will go here, and inside the temporary directory we will make a file named, for example, source process. So source.cpp, we have a source file which will be containing the address. So this address will be basically like, we will printing the address. For example, we are not communicating now with the help of ports, because that will be a very long process. I will be just copying and pasting the values from here to the other processes buffer. Okay, so we have a X that is 10. So X is stored at a memory location inside this source process. Okay, and we will be printing its value so that we can see the value, see the address, and just copy and paste it. It's just that. And now what we will do is wait for input. Now why we are waiting for input is so that we can just come out of the process. We don't come out of the process actually, because if the process exits, then this memory location is no more valid. Like this memory location, the X is no more valid, so for that purpose we will not be exiting it. Okay, and we will keep waiting for the input, and this looks fine. Okay, now let's go for destination. Control O and then destination dot cpp. Now what this destination will have is, this will have IO stream, and now what we will do is we will have a size t variable which will be locating the address. Just it will take input, so basically it's an input, and we will be taking an input inside it. Input. Okay, now so we will be changing this to printf, because printf has this simple way of defining things which lets you see values in actual numbers, not in hexadecimal numbers, because default cout uses hexadecimal numbers, but I don't want to see hexadecimal. That's why I am switching to just seeing integers so that input becomes easy. Okay, now we will take input and we will just pass it to a pointer, integer pointer, that will point to the memory location in the source file. In this source file we are having x, will point to this memory location from this file. So basically what we will do is we will just print it, or equals to input. So ptr is now initialized with inputs address. I will be giving the input, and we will print the value ptr, and we will endl. Now what we are doing here is basically printing this value. So if our end result, that means the value of x is 10 here, if we get 10 here too, then we are fine with it, else we are not fine with it. Let's see what happens. Okay, so let's compile the source file first. So we will compile it using normal things like we will give the output file name to source maybe, and the source.cpp is the source file. So we have done it, and now we will run this thing. So we got this value here, we will copy it just like this, copy, and we will paste it in destination. Now destination, we will open another shell by using control U, control quote, and it opens another shell. So we can just use another pop-up shell. Destination, the name will be destination, the executable name, and the source file name is as usual destination.cpp. And we got some error here, so we will be typecasting this int star. So it's typecasted now. Now it should compile fine. Now we will run this destination and we will paste it. So let's compare this: 14073 14073 7222 7222 72 72 7924 7924, perfectly fine. So we have just copied it and we got a segmentation fault. So we now confirm that stack, like the source file, in our source file this x was stored in the stack. By default, whenever you define a variable, normal variable, not arrays, normal variables like int x, char x, so those variables go into the stack, and the stack contains this value x. Now stack is kind of related to the program, so I might think that okay, so maybe it works, maybe it doesn't work. So now we confirm that it doesn't work, because I just gave the address to another process and it can't access it. You see, it gave a segmentation fault, so basically we can't access it. Now there will be a bit of change here, and we will be defining x but as a pointer, and we will be dynamically allocating the memory, and we will point x to 10, so that now we are storing the value in heap, and the heap will tell me the value, means I will get the address of heap now. Now we have to delete it too. Let's define char c, and or maybe int c, it's totally upon you. Int a, int c, so that we can stop the input. Now we have stopped the input here, and we will be cin is done, delete x. Now this destination is still receiving it in the same way, it's just receiving the reference, that is the address. So basically the source file needs to be changed and destination file will just be the same, because it just needs to access the address and nothing else. So we now have this basic thing. Let's see if it works. Okay, now compile it first, then source. So we got the value of the heap, value of the address that was in heap. Now let's try running it here. Pasted it. Okay, so yeah, we got again a segmentation fault. So that confirms that a process's memory mapping is done in such a way so that another process cannot breach into it. I mean, you can breach into it in a different way, but not like simple ways like this. Okay, by just referencing it, like maybe using GDB you can inject different values and whatnot, but not in this case. So we have reached to a conclusion that we can't access a process's memory from another process on a same computer system. Okay, thank you for watching. Like and subscribe for more videos, or dislike if you didn't like. Thanks for watching.